Hello everyone. Welcome back to Dr. Liu's VCE Chemistry channel. Today, let's learn together about the NHT VCE Chemistry Examination 2025. We will focus on questions related to separate and purify organic compounds. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The correct answer is C. Both 1 and 2. Analysis of statement I. If a sample starts melting at 49 degrees Celsius and is not fully melted at 53 degrees Celsius, then the sample is a mixture. Pure substances, these have a very sharp melting point, typically occurring over a narrow range of 0.5 degrees Celsius to 2 degrees Celsius. Mixtures, impurities disrupt the crystalline lattice of a substance, causing it to melt over a much broader range. A range of 4 degrees Celsius, from 49 degrees Celsius to 53 degrees Celsius, is considered broad and is a classic indicator that the sample is impure, or a mixture. Conclusion: Statement I is correct. Analysis of Statement 2. If the melting point of a sample is lower than expected, then the sample is a mixture. Melting point depression, this is a colligative property. When an impurity is present, it weakens the intermolecular forces within the crystal structure. Because the lattice is less stable, less thermal energy is required to break it apart, resulting in a lower melting point than the literature value of the pure substance. Conclusion: Statement 2 is correct. The following tables shows the composition of an oil, pinene and 1,8-cineol. Victoria distilled this oil in the fractional distillation apparatus shown the diagram below. The correct answer is C. The temperature of the liquid in the distilling flask was greater than 156 degrees Celsius during the distillation. Here is the chemistry-based reasoning for why this statement is true, as well as why the others are incorrect. Why C is correct. In a mixture of liquids, the boiling point of the solution will be higher than the boiling point of the most volatile component, alpha-pinene, 156 degrees Celsius, but lower than the least volatile component, 1,8-cineol, 176 degrees Celsius. As the distillation progresses and the concentration of the higher boiling 1,8-cineol increases in the distilling flask, the boiling temperature of that remaining mixture will rise further above 156 degrees Celsius. To keep the alpha-pinene evaporating, the liquid in the flask must be heated to its current boiling point, which is dictated by the composition of the mixture at that moment. Analysis of incorrect options. A. The melting point of the distillate was greater than 156 degrees Celsius. This is a distractor that confuses boiling point with melting point. 156 degrees Celsius is the boiling point of pure alpha-pinene. Furthermore, the distillate is 80% pure, a mixture, which would actually cause melting point depression lower than pure, not an increase. B. The temperature of the distillate collected in the receiving flask was 156 degrees Celsius. The distillate in the receiving flask has already been cooled by the condenser. Its temperature will be close to the temperature of the cooling water, usually room temperature, not the boiling point of the vapor. D. The distillation was stopped as soon as the temperature at the top of the fractionating column reached 156 degrees Celsius. If the distillation stopped exactly at 156 degrees Celsius, very little distillate would have been collected. To obtain a significant volume of distillate that is 80% pure, the vapor temperature usually hovers near or slightly above 156 degrees Celsius for a period of time. Part 1. Melting Point Determination. Question 23. The presentation first explores how melting points are used to identify the purity of a substance. Pure substances, characterized by a sharp melting point, typically occurring within a narrow range of 0.5 degrees Celsius to 2 degrees Celsius. Mixtures. The presence of impurities disrupts the crystalline lattice, resulting in a broader melting range, e.g., 4 degrees Celsius, and melting point depression, where the substance melts at a lower temperature than its literature value. Part 2, Fractional Distillation, Question 28. The second half focuses on the separation of a two-component oil consisting of alpha-pinene at boiling point 156 degrees Celsius and 1,8-cineol at boiling point 176 degrees Celsius. Key principles explained. Boiling point of mixtures. In a liquid mixture, the boiling point sits between the boiling points of its components. Temperature changes. As the more volatile component, alpha-pinene, evaporates, the concentration of the higher boiling component in the distilling flask increases, causing the boiling temperature of the remaining liquid to rise further above 156 degrees Celsius. Distillate characteristics. The temperature of the liquid in the receiving flask is close to room temperature because it has been cooled by the condenser. To collect a significant amount of distillate, the vapor temperature at the top of the column must hover near or slightly above the boiling point of the more volatile component. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.